we are going to do some functions. Okay, so let's have a look at the questions that I have got for us to do this evening. Let me just get myself sorted out here. Okie dokes, let's get cracking. So the question says the graphs of g of x equals a over x plus p plus q and f of x equals x squared plus 4x minus 5 are sketched below. The equations of the asymptotes of g are x equals -2 and y equals -9. So g cuts the x-axis at point A, which is -8 over 3 and 0, and the turning point of F lies on the intersection of the asymptotes of G. Okay, so having a look at the diagram, that's exactly what they've described to us. Let's get started on the questions. So the first one, 5.1, I think you guys can do by yourselves. They want you to write down the range of F. And the second one, they want you to calculate the x-intercepts of F. So I'm just going to put that there for you. So 5.1 is the range. 5.2 is the x and y intercepts of F. So let's do that. I'm going to let you guys do that on your own because you should be able to do that quite easily. And I'm just going to write that on the side there. And then you share your answers when you have done both, okay? Oh, sorry, Boucher. They wanted the x and y intercepts of F. Okay, so x and y intercepts of F. Okay, so that's my answer for 5.1. I think you guys would have got the same thing there. Oh, sorry, Tisha. Let me just move this up a little bit. There you go. Okay, so in 5.1, we're writing down the range, and in 5.2, we're calculating the x and y intercepts. Is that better? Can you see that okay, Tisha and Boucher? You need the equation of F. Sure. There it is. There's the equation of F. No problem. Okay, so Michelle says y is equal to -5. Quite agree with you there, Michelle. Good job. Indeed, Orotile. Okay, I got the same answer. Absolutely. Well done, Orotile.
Sorry, ma'am.
Yes, Cornelia, go for it.
Can I just find out the x-intercept?
Yeah.
Is it not x minus 5 and x equals 1?
It is.
Because it's x squared plus 4x minus 5.
Yeah, so 1 is equal to, the one root is -5, the other root is 1. Yeah, 100%. So, sorry, oh, I beg your pardon. Yeah, Orotile, oh, you're quite right. Sorry. Cornelia, you're quite right. Orotile, maybe I made a little sign mistake there. Yes, it should be -5 but +1. Yes.
Thank you, ma'am.
Yes. Like Boitumelo's done it. And Michelle, yeah, that's correct. Quite right. Okay, so when we factorized here, inside our brackets, we would have had x plus 5 times x minus 1 is equal to 0. Yeah, so in other words, x is going to be equal to -5 or x is equal to +1, just like that. Okay, thanks, Cornelia. Okay, good job. Thank you. There we go. All right, so that's out of 4 marks. Okay, so I think here what they would have done is they would have given us 1 mark for this, 1 mark for making that equal to 0, 1 mark for the factors, and another mark for the answers. Here, there would obviously just be 1 mark on the answer like that. Okay, good job. All right, so now that our brains are warm, we can hopefully get into some questions that are a little bit more difficult. Now it says to us, determine the values of m for which f of x equals m has 2 unequal negative roots. Okay, so f of x equals m has 2 unequal negative roots. What do we think we should do here? What does f of x equal m mean for us? You can do, Kashandra, but this question does not require a nature of roots interpretation because it's only out of 2. So this is a read off the graph. That's why you've always got to look at the mark allocation before you answer the question, okay? Because the mark allocation gives you at least something of an indication as to how much work is necessary. So because this is only out of 2, I would say that it's unlikely that you have to do nature of roots with this question. What does f of x equal m mean, Matrix? Sure, no problem. What does f of x equals m mean for us? Can anybody? I can understand why you're saying that, Kaiser, but they're not talking about gradient in this case. No, the letter m doesn't represent gradient in this case. Okay, so the question is there on the screen, Carlos? It's question 5.3. It's this one over here. Can you see it? So determine the values of m for which f of x equals m has two unequal negative roots. They share a position on the graph notes. Okay, you want to check the information above. That's fine. There you go. You can look at that. So you've got the graphs of g of x equals a over x plus p plus q. And f of x equals x squared plus 4x minus 5. They give you the equations of the asymptotes. They tell us where g cuts the x-axis. And they tell us that the turning point at f lies on the intersection. It doesn't tell us anything about f of x being equal to m. Okay, so f of x equals m is a simultaneous solution between our graph f of x and a horizontal line. Okay, so remember, if we say here y is equal to m, that would be a horizontal line, wouldn't it? If I say y is equal to x squared plus 4x minus 5, then y is a parabola. So if f of x equals m, what this means is that there has to be a point of intersection between a horizontal line, the line y equals m, and the parabola. So I've drawn this horizontal line here for you guys in red, okay? Right? And the question is asking us, where would there be two unequal negative roots? Okay, so where there are roots, that is where the straight line intersects the parabola. That's what we mean by roots. So where it is right now, what can you tell me about the roots? Are they unequal? Yes, they are unequal, okay? No, they're unequal, Tisha. Okay, because the reason they are unequal is because if I now read off, so this is the one root, if I now read off whatever value of x this is, it's going to be some negative number, isn't it? When I read off this value of x, it's going to be some positive number. This number here on the x-axis and this number here on the x-axis are two different numbers. Unequal, but one positive and one negative. Beautiful, Cornelia. I couldn't have said it any better. All right, that's lovely. Tyler, one negative, one positive. Fantastic. Okay, so we want two unequal negative roots. So where am I going to move the red line? Am I going to move it up? Is it going to help me to move it up? No problem, Tisha. Not going to help me to move it up, is it? Okay. I'm not hyping you up. I'm saying that's excellent. The way that you put that is perfect. You don't have to cry, Cornelia. I was giving you a compliment. Okay, so moving it up is not going to help us in this case because the root on the left is going to continue to be negative. The root on the right is going to continue to be positive. So what we've got to do is move it down. Okay, now remember our system of axes. Here is the origin. Let me just draw it in here for you. Okay, there's the origin. Okay, so I'm going to grab hold of my line and I'm going to move it down. All right, so now when I'm over here, I've still got one negative root and one positive root. Okay, so I'm going to keep moving it down. When it now sits on the x-axis, I've still got one negative root and one positive root. Over here at this stage, I've moved the line here. I've still got a negative root and a positive root. So I'm going to move it down just a little bit more. When I get to this point over here, okay, where the straight line goes through when the straight line goes through the y-intercept, what can we say about the roots? So where the red line is right now, what can I say about the roots? What roots have I got? This root over here is negative, quite right, okay? So this root over here is negative. This root at the moment is equal to 0, so it's not negative. So what I've got to do is I've got to move it down one more time, okay? There we go. Now that I've moved it down one more time, can you see I've now got 2 negative roots because this root over here is negative and that root over there is also negative. If I keep moving it down, okay, now when I get here, all right, now I could say I have equal roots because it's touching, or it's supposed to be touching, in one place only. Okay, so now my roots are equal, but they said they wanted unequal negative roots. So that means it has to be above the turning point, but I can't go above the y-intercept. So between the turning point and the y-intercept. Okay, so that value of m has to be a number. Okay, that is going to be bigger than -9 at the turning point, but smaller than the -5 at the y-intercept. Okay, does that make sense to everybody? Okay, then the straight line and the parabola will touch one another where both roots will be negative. Is everybody good with that? Is that making sense? Cool. Good, Kaysa. I'm glad. Okay, next question, 5.4. If everybody's cool with that, we can move on. Okay, so yes, I think often what happens, Courtney, is that we tend to think of maths as something that's very static, and it's not, it's dynamic. But you know, when we don't teach it using technology, it's very hard for us to move these lines. So I think drawing a line like that and moving it up and down really kind of makes a big difference to help us understand what's going on. Okay, well, at least I hope so. Okay, the next question, 5.4.1. Write down the values of x for which the graph is increasing. Now, I'm going to ask you guys a question, and I don't want you to say getting bigger. What does the word increasing mean when we're talking about functions? What does the word increasing mean? Don't say getting bigger. Increasing means what? So Boyd-Shepp was on the right idea. Okay, what about the gradient? There we go. Lovely, 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 lovely. Yes, Esel Bavuma, positive gradient. Kashandra, where the gradient is positive. Boyd-Shepp being positive. Absolutely. So the word increasing specifically means a positive gradient. Okay, so where is the gradient now positive? All right, so in other words, that region of the graph where it is increasing, the gradient is positive, is from the turning point onwards. Okay, so how shall we write that? Where x That's it, Buhle. Well done. Where x is greater than -2. Marvelous. Well done. Okay, and we're going to get 1 mark for that. Good job, everybody. Next question. Where is g of x smaller than or equal to 0? Where is g of x smaller than or equal to 0? So tell you what, let's get rid of all of the red, because that might make things. So where is g of x smaller than or equal to 0? So what does that mean for us? What are they asking us about here? What does g of x mean? It means the what? What is g of x referring to here, Matrix? Absolutely, Carlos. Okay, so it's referring to the y values. Okay, where are the y values negative on the graph? So let's just put the answer for the other one over here. This is where x was greater than -2, 5.4.2. Where are the y values on the graph going to be? Negative. So, and again, we can use our highlighter to highlight the regions on the graph where this is happening. So where is the line below the y-axis? Okay, so remember here's, sorry, below the x-axis. Here's our x-axis. Our line is going to be below over there and also over there. Okay, so we've got to describe these regions. So Carlos says where x is smaller than or equal to -8/3. Yes, Carlos, that is one of our answers. I'm going to fill that in. So where x is smaller than or equal to -8/3. Or where else is it happening? Okay, so look at the other arm of the hyperbola that I've highlighted in yellow. What would we do here? Okay, so this bit over here, let's see what you guys are saying. Okay. Isel Bavuma, not where x is greater than 0, but I like the fact that you're using the greater than sign. Okay, no. -9, Mohammed and Kaiser, you're looking at the wrong graph. Okay, so the -9 is important for the parabola. Okay, we're talking here about the values of x for which g of x is negative. Okay, so -9 is an output, it's not an input. Okay, not greater than 0. Remember, this is the y-axis over here. So I'm going to highlight the y-axis for you guys again. Here, oh, what kind of straight line is that? My apologies. Okay, so here is the x-axis and here is the y-axis, guys. Let's see what you're saying now. Ah, there we go. It's okay. All right, where x is greater than -2. 100%, Kwanele. Okay, Chiamo. Marvelous. Okay, so where x is greater than -2. Okay, cannot be equal to -2 because of the asymptote. Okay, very well explained. Or where x is greater than -2. Does that make sense to everyone? That's okay. You know what? Isel Bavuma, I'm sure, maybe you can tell me what your name is. We've just been calling you that since the beginning here. But yeah, it would probably be a little bit easier if you had this in front of you and we weren't doing it online. But yeah, that's why I think it's important for me to highlight these things and show you that. Okay. Yeah. Absolutely. It really does make such a big difference to highlight things. Okay, so Cassandra, you're saying you're a little bit lost. Where did we lose you, Cassandra? What's not making sense? No, not where x is less than -2, where x is greater than -2. Did I write less than? No, where x is greater than -2. So in other words, Cassandra, all right, so again, let me use a vertical line. Let's make it a bright color. Okay. So over here, your asymptote. Why is this not grabbing hold? Sorry, Cassandra, just give me 1 second, yeah? I don't know why it's not grabbing hold of my line. No, that's not what I want. I'm going to take my mouse out and put my mouse back in again. Sometimes that helps. No, still not helping. Rats. I don't know what to do with my mouse not working out. Okay, so Cassandra, what I'm trying to show you here, can you see I've drawn a red line, okay? And the red line is over the asymptote, okay? I'm trying to put it over the asymptote. So everything to the right of this line is where x is greater than -2, isn't it? Okay, and that's where this yellow bit is. Okay, so we're talking about this yellow bit over here. All right, it's below the y-axis, sorry, the x-axis, it's below this line. Okay, so this is where g of x is negative, and as it gets closer and closer to your asymptote, that is where x is equal to -2. So anything to the right of that has got to be bigger than -2. All right, so we are just describing this region of the graph over here, okay, on the right-hand side. Okay, where x is greater than -2 is where the other arm is below the x-axis. Yes, we are using, so that's exactly what we've done, Michelle. We've described both parts. We've described both yellow parts. So the yellow part over here, up at the top, this is the bit that's described x is smaller than or equal to -8/3. This bit over here is the one that is where x is greater than -2. So we've described both in our answer. Okay, Michelle? Okay. Good stuff, everyone. Okie dokie. Now they want the equation of G. Okay, the equation of G. G is the hyperbola. Okay, so it takes the form G of x equals a over x plus p plus q. Okay, remember they've given us the equations of the asymptotes. X is equal to -2 and y is equal to -9. Okay, so now they want us to write down the equation. Okay, so I'm going to be quiet for a little bit and I'm going to let you guys try that on your own. Okay, so the equation of G of x, please. Okay, so Cassandra, okay, so that's why you didn't come back. All right, but you do get it now. Okay, No problem. Okay, so we've described both yellow bits. All right, so Kashandra, we're busy on the next question. We're determining the equation of the graph of G.
Lee, someone has asked if you could just scroll down quickly.
Sure. I'm just answering a direct message. Just scroll down quickly. Is that enough? Is that okay? Okay. If you want me to move the screen again, guys, just say so. Sorry, I know we've got to kind of go up and down and up and down and up and down. Okay. All right. Okay, so Carlos, you got minus 24 over x plus 2 minus 9. Mohammed, you got minus 6 over x plus 2 minus 9. Okay, let's see. Can you see, Lee, you got minus 6 over x plus 2 minus 9. Kaiser, all right, good. Kulani, there we go. Well done, and Bushle, nice. Okay, so Carlos, I think you just made a little mistake there. I'm not quite sure how you got the minus 24, but you obviously multiplied something together, but the rest of you are correct. That is exactly the right answer. So I'll just quickly do that on the side here as well, and then we can do the last question. You can start looking at it in the meantime. So the graph of G is translated. So here we would have said, what did I write? We would have done that, and then we would have taken the 9 over to the other side. Minus 8 over 3 plus 2 would have left us with 3. That would have left us with negative 2 over 3, which means that 9 would be equal to negative 3 over 2a. And then we should multiply both sides, multiply both sides by negative 2 over 3 times by negative 2 over 3. And that means that a is going to be equal to negative 18 over 6, which is where we get the negative 6 from. Okay, yes, 100%. Well done, everybody. So g of x is equal to negative 6 over x plus 2 minus 9. Okay, and we're confident in our answer of negative 6 because, again, when we go back and we look at the graph, we can see very clearly that it has been sketched in quadrants. Let's just get rid of all of this drawing all over it again. It's been sketched in quadrants 2 and 4. Obviously, it's been shifted but quadrants 2 and 4. So we were expecting A to be a negative number. Okay. All right, let's go and have a look at the last question. And let's do that. Then we can see what else we can do before we say goodbye. Okay, so the graph of G is translated to obtain graph P. Describe the transformation from G to P if the axis of symmetry of P, or the axes of symmetry of P, are y equals minus x minus 10 and y equals x plus 2. Nice difficult question, isn't it? Okay, so we have to describe a translation of G to P. And they've told us that the axes of symmetry of P are that and that. What do we? Yeah, most people do. You know what, Kaiser, because this is a thinking question, isn't it? It forces us to think. We can't just apply a formula or make something equal to 0. We've really got to think about how we're going to answer this question. Right? Well, what do you know about the axes of symmetry of any hyperbola matrix? What do you know about the axes of symmetry? Can you describe what they look like? What do they do? What are the axes of symmetry of a hyperbola? Yeah, Boucher. Okay, so that they're mirror lines. Sure, I like that. Okay, now Carlos, you're onto something here. All right. Y equals X is our axis of symmetry when we first start doing these. Okay, Y equals negative X. Yeah, 100%, absolutely. They divide the two. Tisha saying something there. Okay, so the idea is, all right, if I can just quickly draw a system of axes here for us, okay. If our graph is sketched in this quadrant here and this quadrant over here, right, we have an axis of symmetry that has a positive gradient. Okay, it's supposed to be a straight line. That's really badly drawn. And this is what you were saying, Carlos. This is the line y equals x. Okay, so now this is before quite right Orotile. So that's a mirror image of it over the line y equals x. There is also another line, and it cuts the hyperbola in half this way. Okay, and that's the line y equals negative x. Now, this is what's happened. Okay, Boitshepo's got the answer already. Okay, Boitshepo, that's lovely. Let me just check what I did, Boitshepo. Okay, my answer was slightly different to yours. Okay, but we'll talk about it now. Okay, so what we can always say about these axes of symmetry matrix is that they always go through the origin. Okay, now that is, in this situation, what I've just drawn you here, this is a graph that hasn't been shifted to the left or to the right. If we consider this graph over here, all right, this graph has been shifted to the left and it has been shifted down. So what we would say here is that there is one axis of symmetry. Let's do it in blue. One axis of symmetry, okay, that has a negative gradient. That's this line over here. Okay. Then there is an axis of symmetry that has a positive gradient. Okay, let's draw it. That would be this line here. Right? So these axes of symmetry shift with the graph. Okay, so when the graph gets moved to the left and gets moved down, these axes of symmetry move with the graph, and they always go through the origin and the new origin. So our new origin, our origin is no longer located at 0 and 0. Okay, this is our original origin over here, which was 0 and 0, okay? But now it's located over here. The coordinates at this point are -2 and -9. The two lines intersect one another at that point. Okay, so this is the theory that we need to know. The two lines intersect one another at that point. They go through the same X and Y at that point. I'm dropping major hints now. Okay, how are we going to describe the transformation from G to P, given that these lines go through the same point and are equal to one another at that point? What are we going to do with the information that's given to us? Think, think, think. Okay, so again, I'm going to let you look at the picture, okay? The axis of symmetry with a negative gradient and the axis of symmetry with a positive gradient intersect at this new origin. They always do. So for points of intersection, what can we say? The two are? Okay, so at this point of intersection, the two are what? Equal, absolutely, absolutely. They're equal to one another. Yeah, it's a simultaneous solution, absolutely. All right, so once this transformation has taken place, all right, these axes of symmetry are still intersecting one another at our new origin. So we can make them equal to each other. So minus x minus 10 is equal to x plus 2. Okay, because they're equal to one another. Let's collect x as one side. So that's minus x equals 2 plus 10. So this gives us minus 2x is equal to 12. Divide both sides by -2. X would be equal to -6. Now we can sub into either equation and work out the value of y. So let me just use this one because it's the easiest. Okay, so now I've got -6 plus 2, which means that y is equal to -4. Okay, these are my new asymptotes. Okay, so the x equals -6 is my new vertical asymptote. Y equals -4 is my new horizontal asymptote. All right, so now I have to explain, all right, what is happening. I have to describe the transformation. All right, from G to P, okay? So from G to P, so where's the equation? There it is, okay? So the equation of G, it's the line y equals -6 over x plus 2 minus 9. So what's happened in terms of the movement? Let's first do the movement up or down, okay? What two numbers are we comparing with one another in this case? So up and down, we've got to compare y equals -4 with what number? With the, let's see. Absolutely, Boucher, with the -9. Okay, because remember, this over here is our vertical movement, isn't it? Oh, Cassandra, we all do. We all do. Don't feel bad. That's why, you know, it's so nice for you to be able to come to Watobe and we can do these sorts of questions and we can talk about it because, you know, at least it gives you some exposure to problem-solving sorts of questions and things where we need to think. Okay, we all got kicked. Courtney, me, all of us. All right, but is it making sense now, Kashandra? Now that we're discussing.
I think Kashandra might mean that she got kicked off the Zoom meeting.
Oh, okay. Sorry, I thought she meant the question kicked her. Sorry. I never know when they're talking slang or whether they actually mean off or I always seem to get it wrong. Okay. All right. So we're comparing, as we were saying, we're comparing y equals -4 to the y equals -9. All right, so if we've moved from -9 to -4, that means we must have moved what, matrix? We must have moved how many units and in which direction? Let's see what you get. Absolutely, guys. Lovely. Okay, so 5 units up. Beautiful. Okay, there we go. Now we've got 1 mark. All right, out of the, no, well, I think we've got more than that. I'm sure there's a mark for this and a mark for this and a mark for 5 units up. And now, okay, the tricky one, all right, to compare what's happened moving left and right. Okay, so here, our axis of symmetry, our vertical axis of symmetry for g of x is the line x equals -2. Okay, it's the line x equals -2. So x equals -2 is the current axis of symmetry, vertical axis of symmetry. So what's happened? Okay, 4 units to the left or 4 units to the right. What have we gone? Absolutely. Oh, you guys are amazing. Okay, we've gone 4 units to the left because we've gone from x equals -2 to x equals -6. Okay, so that is 4 units left. Lovely. Okay, and there we go. We got 4 out of 4. Beautiful. Well done. Okay, so yeah, 5 units up and 4 units to the left. How are you guys feeling? Michelle, I'm just thinking about what you're asking me here. So it's only in trig functions where the Michelle, all functions behave in the same way. So in a trig function, if you say y equals sine x minus 45 degrees, this means that there has been a shift 45 degrees to the right. Okay. So here we went from -2. So we went from the line x equals -2 to the line x equals -6. So that means that we shifted 4 units to the left. Okay. Oh, okay. All right. Okay, that makes sense. Are there any questions before we move on? I don't think we've really got much time left, unfortunately. Anything anybody wants to ask?
Ma'am?
Yes, Rachel, go for it.
Ma'am, can you please re-explain how you concluded that it moved 4 units to the left?
With pleasure. All right, no problem. Okay, and I see, Kaiser, you've also got a question, so we can talk about that. All right, so are you happy with where the x equals -6 comes from, Rachel?
Yes, ma'am.
Okay, so in other words, if I draw just quickly a set of axes here, there we go. Okay, so there's my set of axes. If I want to draw the line x equals -2, my line would be a vertical line, and it would be here. So that's where the current g of x's vertical asymptote is. After this graph is transformed, okay, it's now sitting over here, right? So now the equation of the vertical asymptote, let's just do it in red, is over here, okay? Because this is now the line x equals -6. So in other words, it's gone from the green to the red. From green to red. So that means that we have to have moved 4 units to the left-hand side. 4 units left.
Oh, ma'am, I see where I made my mistake.
Okay.
I didn't look at the 2 as like -2. I thought it was +2.
Oh, no. Okay, so now it's very easy for us to do that, because remember, x plus 2 means it's been shifted 2 units to the left. That's why I started here. And I know, because it's so easy to make that mistake. We've got this here, but it actually means that the asymptote is x equals -2. Okay.
Thank you, ma'am.
Pleasure. Okay.
Madam,
Yes, Kaiser.
can you please show us a question where we have to prove the g of x? They'll give us the set of numbers where we have to prove g of x. I'm struggling with that.
So when you say prove g of x, what do you mean exactly, Kaiser?
They would tell us g of x equals like a over x plus p plus q. They'd give us the values. They prove that those letters equal.
Oh, okay. So now when they give you a question like that, Kaiser, you have to pretend like you don't know that that's what those values are. So I see there's another question, Michelle. I'm going to answer that as well. All right. Let me just scooch down here quickly. All right. So Kaiser, to answer your question, all right, what they often give you in a situation like this, and I mean, just forgive me because this is a really quickly drawn one. Let's say that's -1. Let's say that's 3. And let's say the value over there, let's pretend that that's -4. All right. And then they come along and they say to you that this is the graph of g of x. And they want you to say that, show that A equals 1 and B equals whatever and C equals whatever it might be. You've got to pretend like you didn't know that they gave you that information, Kaiser. So you have to sub into the appropriate formula for that particular function. So in the case of a parabola, if they've given you the 2x intercepts, you would use y equals a x minus x1 x minus x2 if you've been given the roots. Okay, so you would say y, and it's your job to work out the value of a first. So here you would say x plus 1 times x minus 3. So those are the roots that have gone in first of all. Your x and y is another point that lies on the line. So that's why they've given us 0 and -4. So whilst y is equal to -4, x is equal to 0. Now, again, I've just made these answers up, so A is not going to have a nice number to it. But in this case over here, we're going to say 1 times -3 is -3A is equal to -4. So that means that A is going to be equal to 4/3. Okay, and then you would take that and you would now go and sub it into this line, y equals 4/3 times A plus 1, sorry, x plus 1 times x minus 3. And then you would have to multiply all of that out, and then you would get your values for B and C. Okay, Kaiser?
Okay, thank you, madam.
All right, it's a pleasure. Now, there was another question about roots, okay? So roots are all about x-intercepts, okay? So now, guys, here is a set of x and y axes. There's x, okay? So when a parabola does this, okay, its turning point is below the x-axis, roots are non-real. Or if a parabola did this and its turning point was above the x-axis, then roots would be non-real because it's not intersecting the x-axis. So both of these have what we would refer to as non-real roots. Okay, so it's not the shape. The shape of the parabola has got nothing to do with it, okay? It's the fact that neither of these intersect the x-axis. When roots are real, it means that the parabola has a turning point on the x-axis, okay? Sorry, roots are equal. Okay, so the roots are real now, but they're real and equal. So the parabola has a turning point on the x-axis. So here we would say roots are equal. Okay, so here roots are equal. So in the case of roots are non-real, here the value of delta is negative. Here, for roots are equal, delta is equal to 0. Okay, and then roots that are real means it cuts in 2 places. Okay, shape again, it doesn't matter, it cuts in 2 places. Then we would say that roots are real. Roots are real. So in this case, delta is positive. But this is where there's a bit of a split or a bit of a division, okay? Because delta, when it's a positive number, it can be a perfect square, or it's not a perfect square. Okay, so if it is a perfect square, all right, then your roots are going to be real, unequal, unequal, and rational. Okay, if it's not a perfect square, your roots are going to be real, unequal, and irrational. Okay, so that's just a quick summary of the story with the roots. Okay, Michelle?
Thank you, ma'am.
Oh, it's a pleasure.